Hi, in this video, I will be showing you problem number 9 of chapter 3, section 8 from the practice exam 2. The half-life of cesium-137 is 30 years. Suppose we have a 160 milligram sample. A. Find the mass that remains after t years. B. How much of the sample remains after 60 years? Round your answer to 2 decimal places. After how long will 1 mg remain? Round your answer to 1 decimal place. So let's assume let m of t be the mass, in milligram after t years. So m of t follows the model m of 0 initial mass times e to the exponent kt, where k is the related decay rate. This is a decay problem, so it's a decay rate. K denotes a decay rate. The initial mass is given, which is 160 milligrams. So m of 0 is 160 e to the kt. Then it says as half-life of cesium is 30 years. So for the mass of 160 to become half of its size, half of 160, which is 80, it takes 30 years. So we have to use that condition that half-life is 30 years. So time equal to 30 when m of t becomes 160 over 2. So m of t is 160 over 2, half of the initial mass. The initial mass is 160. So half of initial mass equal to 160 times e to the k. Now it is 30 because half-life is 30. So here 80 equal to 160 times e to the exponent 30k. So divide by 160 both sides. So you get 1/2 equal to e to the 30k. So we need to find out what k is. So 30k will be equal to ln of 1/2, or k will be equal to ln of 1/2 divided by 30. This we can find out from our calculator. This will be negative 0.0231. But for the problem, it's better to keep it as an exact value. This negative sign shows that this is a problem of decay. K equal to ln of 1/2, which is ln 1 minus ln 2 divided by 30. So it's better to keep that as negative ln 2 over 30, as ln 1 is 0. If I keep it this way, it may be an exact value. So find the mass that remains after t years. So we need to substitute that in m of t, which is 160. We are substituting that into this relation. 160 e to the exponent negative ln 2 over 30 times t. So if we do some algebra here, we can reduce this to 160 e to the negative ln 2 times t over 30. Then this negative sign can be taken as an exponent of 2 by power rule of logarithm. So it is e to the ln 2 to the negative 1 t over 30. E and ln are inverses of each other, so that will get cancelled out. So 2 to the negative t over 30. So that will be the mass after t years. That answers the first part of the question. This can be written in terms of milligrams. This is first part of the question. Now let's do the second part. How much of sample remains after 60 years? Round your answer to 2 decimal places. So part B is m of t is 160 times 2 to the exponent negative t over 30. We are asked to find out how much of the sample remains after 60 years. So this t must be replaced by 60. So it is 160 times 2 to the exponent negative 2. It's also equal to 160 divided by 2 to the power 2, which is 4, which is equal to 40 mg. So this is part B. So mass after 60 years, mass of the sample after 60 years is 40 milligrams. Then part C is asking after how long will only 1 mg remain. So m of t equal to 1 mg. Now we have to find out what t is going to be. So let's take the model. So m of t from part A, m of t from part A, that is 1 mg, which is equal to 160 2 to the exponent negative t over 30. We have to solve for t. So if we divide both sides by 160, so 1 equal to 160 times 2 to the power negative t over 30. Divide both sides by 160. So we get 2 to the power negative t over 30 equal to 1 over 160. So negative t over 30. So if we take ln on both sides, negative t over 30 times ln 2 will be equal to ln of 1 over 160. So isolate the t, that is negative t over 30 equal to ln of 1 over 160 divided by ln 2. So now if we solve for t, t would be with a negative sign, then we'll have to multiply both sides by 30. So negative 30 times ln of 1 over 160 divided by ln of 2. If you compute this in the calculator, it will come out to be 219.7 years, because the question is asking us to decimal it to 1 decimal point. So it's 219.7 years. So for the sample, which started off with 160 milligrams, to reduce to 1 milligram, it takes 219.7 years. Hope this video helps.